Hi everybody, thanks for tuning in again. This video will introduce you to the complex numbers in polar form. Actually, I probably should say it the other way. Polar forms of complex numbers. Sometimes we also call them the trigonometric form of a complex number. So recall that a complex number written in a plus bi form, where a and b are both real numbers and I is this imaginary unit, the square root of -1. Okay? Now, you may not have thought about those numbers in terms of how you could graph them, but they can be graphed on a rectangular plane. Just where the horizontal axis is what's called the real axis, and the vertical axis is called the imaginary axis. So you have A on the horizontal part and the BI on the vertical part. And so any point in the plane there has two parts, A plus BI. A is the horizontal part and B is the vertical part. And so they can all be located this way. And so all the operations that we do, simplifying, multiplying, squaring, all of that stuff has kind of a component, a graphical component in this thing that we sometimes call the complex plane. Okay? However, just as with real numbers, horizontal and vertical distance away from the origin are not the only possible attributes of a point on this plane. Just like in real numbers, we could consider also the r, that distance away from the pole, or Pythagorean distance you might call it, away from the pole, away from the origin, and the angle there that in standard position. So we have r and theta once again, only now we're talking about imaginary numbers. All right? But the geometry and the math are really exactly the same. It looks a little bit more gnarly with the imaginary eye hanging around in all of this stuff, but the actual math is identical to the real numbers. In other words, r is equal to the square root of a squared plus b squared. Theta is the inverse tangent of b over a. Oh, by the way, that r there is sometimes called the modulus. That's the distance from the pole to the point. Kind of a trivial, sort of strange little word. Doesn't matter that much, but that's what it's called anyway. The distance from the pole is called the modulus. And also true, like as in real numbers, a is equal to r times the cosine of theta, and b is equal to r times the sine of theta. Okay, so those features of a complex number are true, going from rectangular to polar form here, just like real numbers, x, y going to r theta. So well, anyway, this leads us to the actual structure of the polar form of a complex number. So for some reason, mathematicians like to use the letter z to represent complex numbers, and that's kind of a different story. I won't go into it here. But so if z equals this a plus bi, where a and b are both real numbers, okay? And we also keep in mind that a is equal to r times the cosine of theta, and b is equal to r times the sine of theta. Well, then we could write in polar form this imaginary number z. We could write it in polar form as z equals r cosine theta plus r sine theta times I. And that's just a direct substitution there of a and b with r cosine theta and r sine theta. And that pretty much is it. We simplify our final form slightly by factoring out the r and writing it like that. R times the cosine of theta plus I sine theta. That structure right there is called the polar form of a complex number, or the trigonometric form. Okay? So we've got a plus bi in rectangular form, r cosine theta plus I sine theta in polar form. And I thought it might be a good idea to kind of summarize the four different types of numbers that we've been talking about here recently, and dividing them up into real versus imaginary numbers and rectangular versus polar numbers. Okay, so a rectangular real number is what we call a number in xy form. It's a point on the rectangular plane in xy coordinates. The imaginary numbers on a rectangular plane are a plus bi. So those are just two forms that we're very familiar with. The polar numbers, in the real numbers that is, are just r comma theta, and in the imaginary numbers in polar form are this new structure that we just learned about, r times cosine theta plus I sine theta, and it's also called the trigonometric form sometimes. Okay? So just a couple of examples of polar complex numbers. There's one. Here's another one. Notice the theta is always the same for both, and you put that radius, or that modulus really, outside the parentheses like that. You could locate these points on a polar grid. There's a pi over 6 more or less, and so 3 units away from the pole, that'd give you that number right there. Pi, radians in standard form, is over there on the left side of that circle, and so 2 units away from the pole would locate that point right there. So these points have location, and we can do other things with them. Future videos we'll talk about multiplying and dividing complex numbers in polar form, as well as raising to powers, and then of course the persistent problem of converting between rectangular and polar form of complex numbers. Okay, thanks very much for watching. See you soon, and be well. Bye-bye.